Our project, sponsored by ATA Engineering, focuses on the design, building, and testing of a fully operational mechanical impulse cryoshock test table. ATA Engineering is renowned for providing high-value engineering services to help solve a variety of product design challenges through design, analysis, and test. One of the key focus areas is shock analysis. Shock analysis is highly necessary in the aerospace industry. For example, spacecraft and their payloads experience shock at various points during launch. This shock is often generated by pyrotechnic separation devices, which generate extremely short duration but very high acceleration shock waves known as pyroshock. While the main spacecraft structure is typically designed to withstand these loads, smaller internal components such as electronics are much more sensitive and can be damaged by high-frequency shock vibrations. The MIPS test table enables ATA to combine their analysis and test capabilities to provide a one-stop shop for shock test and analysis. Developing off of a pneumatic firing mechanism designed previously by a ME-150 team in 2025, our design safely and repeatedly launches a 1 kg slug at an impact velocity of 6 to 13 meters per second with a half a meter per second accuracy, eliminating double impacts experienced by the previous team. It also incorporates a remote firing mechanism and venting system for safe operation. The pneumatic firing mechanism remains the same, where pressurized air is fed into a tank. A remote actuated solenoid is then opened, letting the air into the nozzle block chamber. The slug is then propelled upward until contact with the resonant plate. After the firing solenoid is closed, a venting solenoid is actuated. To prevent double taps experienced by the previous team, the top of the barrel was drilled with holes for additional passive venting. To support the pneumatic firing mechanism, our team designed and built a test table which also supports the resonant plate. The resonant plate serves as an impact surface for the slug and produces a specific shock response depending on how the plate is sized and tuned. The test articles are placed directly on top of the resonant plate, where high-frequency shock vibrations are directly induced into the part. Improving on the previous team's velocity sensor system, our team designed a setup that uses the venting holes as sites for IR brain brake sensors to accurately measure the velocity of the slug after each firing. Using this setup, we were able to perform over 100 tests, recording impact velocities from 6 to 13 meters per second within a plus-minus 0.5 meter per second accuracy.